Howdy y'all, welcome back to Multar Aviation. So this is a third video of my Aviation Weather Part 9 series where I'm talking about fronts, air masses, and so make sure to subscribe. That way you get notified every time I come out with a new video, because the next videos I'm going to be talking about cold fronts, stationary fronts, and occluded fronts. But in this video, I'm going to be talking about warm fronts. So hey, I'm Dr. Andy Molter. I'm a flight instructor at CFI IIMEI. I'm a former corporate pilot and I'm a professor of aviation. And aviation weather is one of the classes that I teach. So, you're getting a free college education just here on YouTube. And so a warm front occurs when a warm mass of air advances and replaces a body of colder air with a gentle slope. And so this is kind of what it looks like. And I'll go ahead and give you my laser pointer here. Um, but yeah, so you have this warm air mass that gently rides over and takes over this colder air mass. And remember, it's all relative. So this warm air could be 100 degrees, and this cold air could be 90 degrees. It's just that this is warmer, so we depict it with warmer red colors, and the colder air is in fact colder because it's 90 degrees instead of the 100 degrees. And then you see in the top of this picture here, the red half circles kind of show you the direction that that warm air mass is moving. And so a warm front moves relatively slow compared to some other fronts, typically only 10 to 25 miles per hour. And warm fronts are warmer than the air it's overtaking, and it also often has very high humidity. If you go back and watch when we're talking about humidity, because the air is less dense, there's more room that it has to be able to hold moisture. Now, warm fronts are typically generally very stable, and as the air ascends, the air cools to its dew point, and because the air is stable, that's where we can start to get like fog, stratus type clouds, and steady precipitation. And so here's another picture, and this picture I got from the Pilot's Handbook of Aeronautical Knowledge. Typically I recommend that you use the Aviation Weather Handbook when learning about weather. But for this, whenever we're talking about fronts, I actually recommend reading the Pilot's Handbook of Aeronautical Knowledge. I think it's chapter 12, uh, and I think it does a great job of explaining fronts. And so here we have this warm air mass, and it's moving slow, about 10 to 25 miles per hour. So it's gently riding up over this colder air mass. And because it's gently riding up, we would say that it's a stable or stable air mass. And so because it's stable air, we're going to get stratus type clouds. Now, near the surface here, we've got nimbostratus. So remember, so nimbo just means rain, and stratus, stable type of cloud. And you'll notice that this goes over a long distance. So here's St. Louis, Indianapolis, Columbus, Pittsburgh. So it could stretch hundreds of miles. And we just keep on having these different types of stratus clouds like altostratus, cirrostratus, and cirrus. Um, and if you notice here, what happens as we go up in altitude from the surface? As we go up in altitude, the air's cold and then it increases in temperature. And so typically we have the standard lapse rate for temperature is 2 degrees Celsius per 1,000 feet, where it decreases in temperature, but we have an increase in temperature. So that we would call that a temperature inversion, and temperature inversions indicate stable air. All right, well, that's it for this video. So in the next video, I'm going to be talking about cold fronts. So make sure you subscribe so you get notified when that video comes out. And if you have any questions, leave them in the comment section. I'm happy to answer them. All right, you have a great day. Bye.